So hello friends, welcome back to our channel Adam Education. Since we have finished the first chapter in chemistry, today we are going to start a new chapter and we will do it from maths. We are going to start the new chapter Trigonometrical Identities, which is a very interesting chapter and which will be used throughout your life. So what do you mean by trigonometrical identities? Trigonometrical identities chapter basically deal with a right angle triangle and some particular relations related to the trigonometric ratios which you have learned in class 9. So we will just do a quick recapitulation of whatever we have learned in class 9 and then we will move on to questions. So over here, as you can see, I have taken a right angle triangle and so let me consider this particular angle to be theta. So as a result, the angle which will be opposite to theta, that will be your height, and the side which is in the same surface where theta lies will be your base. Don't have any unit because they are ratios, so they are unitless. They do not have any particular unit to itself. Next, we also know about these reciprocal relations which I just told you. Sin theta can also be written as 1 by cosec theta. On the other hand, cosec theta can also be written as 1 by sin theta. They are the inverse of each other. Similarly, it applies for cos theta and sec theta and tan theta and cot theta. So from these three relations which we just saw, we can say that sin theta and theta, we can write it as cos theta by sin theta. This particular relation will also be used in a lot of questions which we will see. The last one is the square relations, where we have sin square theta plus cos square theta is 1, sec square theta minus tan square theta is 1, and cosec square theta minus cot. We are going to begin with that. And if both the sides look simple, we can start with either of the sides and eventually we can prove the other part. So the thing is, the more you practice, the more you become accustomed with these type of questions, and then as soon as you see the question, you are able to identify that okay, I have to do it in this way, okay, I have to do it in that way. So a lot of practice is essential. So let's begin with LHS here. So LHS, in LHS we have tan theta plus cot theta. So we will convert tan theta and cot theta to sine and sine and cos. So tan theta is sine theta by cos theta. Similarly, cot theta is cos theta by sine theta. So as you see, we have got two fractions. So let us find the LCM. So cos theta into sine theta is our LCM. So we have to practice extensively. So this is the first question. Let's do another question. Over here also we have to prove. So as we see now that in the left hand side the expression looks a little more complicated. So we will begin with the left hand side now and then we will eventually prove the right hand side. So let's see. So let's begin with LHS again. So in LHS we have cosec A minus sin A into sec A minus cos A. Bracket we will have sin A 1 minus sin square A. Now for the second bracket we will have cos A in the denominator minus cos square A sin square A, which we just saw, by cos A, and then we have 1 by, we have fractions, but I am choosing left hand side because it contains an invert ratio. It does not contain the direct 3 ratio, so I will begin with the left hand side. You can begin with either. So LHS is sec A minus 1 divided by sec A plus 1. So sec A can be written in terms of cos A, 1 by cos A. So let us do that because in the right hand side we have to prove in terms of cos. So we will convert sec into cos. So 1 by sec A is 1 by cos A minus 1 divided by 1 by, this is equal to RHS. Very simple. Just 2 steps and we are done. RHS proved. Alright. Let's see another question now. 1 plus tan A whole square plus 1 minus tan A whole square. We have to prove that this is equal to 2 sec square A. So as we can see that the left hand side looks a little more complicated. So we are going to begin with that itself. Tan A whole square. Okay. So I don't find, we just saw in the relation. Let me just recall for you once again. Sec square A minus tan square A is 1. So sec square theta can be written as 1 plus tan square theta, which we just saw now. So hello friends, we are back again. We have 4 more questions to do and then we'll finish the session for today. So let's see, we have to prove sine A by 1 plus cos A plus 1 plus cos A by sine A is equal to 2 cosec A. It's very clear that we have to begin from the left hand side because it looks really very complicated. So let's begin. So your LHS is sine A by 1 plus cos A plus 1 plus cos A by sine A. So you have to simply do the LCM out here because there's no other option. We cannot make any conversions also. So the whole square, we are getting 1 plus cos square A, 1 plus cos square A plus 2 cos A divided by cos B, and in the numerator we will have cos square A, no I'm sorry, cos A cos B, cos A cos B plus sin A sin B. Yeah. Similarly, in the denominator, the LCM is sin B cos A. Make sure you don't write it as sin A cos B just with the intention of cancelling it out because it would be wrong. Now we have in the numerator cos A cos B is 1 and B square is sin square A. You should be very much accustomed with the identities which you have learnt in the lower classes so that you can, your chapters will also use those knowledge of the identities. So a square minus b square can be written as a plus b into a minus b. So 1 plus sin a into 1 minus sin a plus b into a minus b, and in the denominator we have sin a into 1 minus sin a. 1 minus sin a and 1 minus sin a will get cancelled out and we have 1 plus sin a divided. Now coming to our last question for today, we will finish this and then we will wait for the next session. We will do much more questions in the next session. Let's see, we have to prove that square root of 1 minus cos a divided by 1 plus cos a is equal to sin a by 1 plus cos a. So whenever you have such square root questions, always remember that you have to multiply the expression with something. Always, but with what we will multiply, we will try to understand it. You don't have to memorize. It will become very clear once you start understanding these things. So square root we are going to begin with the left hand side because it is complicated. So LHS, let me write the LHS. Square root of 1 minus cos a divided by 1 plus cos a. As you can see in the answer, in the right hand side you have 1 plus cos a. Since we will multiply it with by 1 plus cos a, I'm just extending the square root a little more. So 1 plus cos a, and always remember